Hello dear students, so we are coming to the fifth questions of electrostatics. So the question is given 2 point charges Q1 and Q2 such that Q1 into Q2 is less than 0. What is the nature of force between them? So you people can see question number 6a. Q1 into Q2 is less than 0. What does it mean? It means that the sign of the two charges Q1 and Q2 are opposite. That means if Q1 is positive, then Q2 is negative, and other way around, if Q1 is negative, then Q2 is positive. So in that condition, they are opposite kind of charges, and we know that when we have opposite charges, they attract each other. So when you have this situation, we can say that two charges are going to attract each other. So nature of force between them is attractive. So coming to the B part of the fifth question, define dielectric constant of a medium in terms of permittivity. Now, dielectric constant. Dielectric constant is represented by K, and it is permittivity of the medium to permittivity of vacuum. I repeat once again, dielectric constant is represented by K, and it is the ratio of permittivity of the medium to permittivity of vacuum. Please remember, dielectric constant is also represented by relative permittivity. And once again, this will be also representing what? Permittivity of the medium to permittivity of vacuum. So the question was define dielectric constant in terms of the permittivity. So this is the definition. Dielectric constant is equal to permittivity of the medium divided by permittivity of vacuum. So what will be the unit of this? No unit, because it is the ratio of two same physical quantities. Now coming to the C part of the fifth question, define Coulomb as a unit of charge. Define Coulomb as a unit of charge. So to define this, what we have to take expression of force in case of Coulomb's law. Let us say we have got the 2 point charges Q1 and Q2 placed in vacuum, and separated between separation between them is R. So F is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by R square. Now let us say Q1 is equal to Q2 is equal to 1 coulomb, yani both of them have got charge of 1 coulomb each, and let the distance between them is equal to 1 meter. Is it okay? We already know 1 over 4 pi epsilon naught has got the value 9 into 10 raised to the power 9 Newton meter square on Coulomb square. Is it okay? So, in case for this situation we obtain the value of the force, it will work out to be, since all units are SI units, we need not write the units again and again, and we will get 9 into 10 raised to the power 9 into 1 upon square of 1. Is it okay? And we get the answer for force in SI units, that is 9 into 10 raised to the power 9 newtons. So on the basis of what we have obtained over here, we can define the Coulomb as a unit of charge. So let us define it now. So we can say 1 coulomb or coulomb is such a unit of charge which when placed at a distance from an identical charge exert which when placed at a distance of 1 meter from an identical charge in vacuum exert a force on each other equal to 9 into 10 raised to the power 9. I repeat once again, 1 coulomb is that charge which when placed at a distance of 1 meter from an identical charge in vacuum exert on each other a force of 9 into 10 raised to the power 9 Newton. Is it okay? So coming to the next question, the question is the relative permittivity of mica is 6. What is its absolute permittivity? So now please remember, relative permittivity, which is same as dielectric constant, it may be defined as permittivity of mica to permittivity of vacuum. Once again, relative permittivity or dielectric constant of mica will be given by permittivity of mica divided by permittivity of vacuum. So this value they have told is equal to 6. So therefore, if we want to find out the absolute permittivity of mica, how do we get it? It is permittivity of mica is equal to 6 times of epsilon naught. Now what is the value of epsilon naught? It is 8.854 into 10 raised to the power minus 12 Coulomb square upon Newton meter square. This will be the unit. In case you have, so you will multiply this and obtain this answer. You can come to know the answer from here itself. This is what you have to remember here, simple multiplication you have to do. Now, sometimes there is a tendency that people get confused about this unit of permittivity. In case there is any confusion, always recall this formula. Is that okay? So, we take epsilon naught this side and we get 1 over 4 pi and we get Q1, Q2, we get F R square. Got it? F goes in the denominator over here. Is that okay? Now let us see the units. No unit for this. And coming to what is the unit of Q1 and Q2 product of this? It will be Coulomb square. What will be the SI unit of force? Newton. And what will be the distance unit in SI? Meters. So Coulomb square upon Newton meter square. So in case you forget, you can find it out within no time. So with this, we complete the 5th question. In the next video, I will be covering the 6th question, some more concepts on electrostatics. Thank you. See you in the next video.